Like the game, correct. Good game. Good game. I like Half-Life 2. Very good. But where is Half-Life 3?
You know the Steam's CEO, I don't know his name in English. The G what?
Oh, the big guy.
Yeah.
Him.
He don't know how to say tree. Everybody
Yes,
knows.
he doesn't know how to say tree. Yes, yeah. I want it.
Yeah, maybe in the future. Half-Life.
I've been waiting since high school for it.
Yeah, I think in my primary school I played the Half-Life 2.
Yeah. Terrible.
I like the gun. This gun can move.
Yeah, the gravity gun.
And
the crowbar.
Yeah,
Crowbar.
Yeah.
Good game. Good game. Okay. Half-Life now. You got that, Ben? Yeah. Okay. So actually, Summer, do you know what Half-Life means?
Yes.
You do?
Yes.
What's it mean?
It's like the U238.
Yeah.
It's too difficult. I can't say it in Chinese.
Okay.
Yeah.
Well, look, okay. So we know that n equals n0 e minus lambda t. And we know from maths class what this graph looks like. It looks like this. It decreases exponentially. So, what's interesting is the time required for half the sample to decay is the same regardless of where we look. So what I mean is, let's take this example. Okay. There is 100 moles. How long until I have 50 moles? 2 seconds. Yeah?
Yes.
Okay. There is 25 moles. How long until I have 12.5 moles?
6.
Yeah, another 2 seconds. Yeah?
Yeah.
So it doesn't matter where you start. For this data, it always takes 2 seconds. Yeah. Yeah? You get the idea?
Yes.
So you can see 2 seconds I have half. 2 seconds I have half. 2 seconds I have half. So this gives us the idea of half-life. And half-life of a radioactive sample is defined as the time required for exactly half the sample to become non-radioactive. Yeah.
So everyone likes U238 also be half.
Yeah.
But
Very long time, I think.
yeah, it's very long time.
Yeah.
If the 1 second is half, why is still spend too long time?
No, it's not. No. This is my example. Is 2 seconds. For something like uranium is like, what is it, like 100 years or something? I don't know, I can't remember. Years.
Yeah.
Takes years for it to go in half. Yeah. I know, for example, something like carbon-14 is radioactive. And the time for it to become half of it to become not radioactive is about 5,000 years. So, for example, if you have 100 grams of C14, I think after 5,000 years you'll have 50 grams of C14 and then plus, like 50 grams of something like nitrogen, I think, or something like that. So half of it is left after 5,000 years. Yeah, it's okay? Yeah. Okay, so if you can write this definition down. Yeah. Easy lesson today, first class. Yeah? Got that? Yeah. Okay. Here's the formula for half-life. Decay constant multiplied by the half-life should equal log 2. So you could say I'd either like this, the half-life is log 2 over decay constant, or you could also say decay constant is log 2 over the half-life. You can do it both ways, so that's the formula. No ink?
So the decay constant will give us in test
Or yeah, one or the other. Easy peasy, yeah? Continue? Right. Just one example. Okay. This is what I was talking about. C14 has a half-life of 5,730 years. What is the half-life in seconds? So, calculator. 5730 multiply.
365
Multiply.
24
Multiply.
3,600.
So, that's the half-life in seconds. Thank you, Ben. Summer, have you got your calculator?
1.1 times 10 11.
Okay. B. What is the lambda, the decay constant? Okay. So, decay constant will equal log 2 over that answer. So, what's that then? Isn't it? Times 11 minus 11.
No, the first name.
Oh, 1.8.
Yes, 1.8.
Okay.
So 3.85 10 minus 12.
Okay? Yeah? The molar mass of C14 is 14 grams. How many moles are in 100 grams? Okay. What's that? How do you get that? The molar mass is 14 grams. How many moles in 100 grams? Thank you. What is it?
7.14.
Yeah? C14 will decay into N14. In 100 grams of C14, how long until we have 25 grams? Okay, well, to go from 100 grams to 50 grams, that's one half-life. 50 grams to 25 grams, that's another half-life. So the answer is 5730 plus 5730. Yeah?
Yes.
11,460 years. Okay. And lastly, how long until we have less than 1 gram? Okay, so let's have a look here. Less than 1 gram, so E. So first we have 100, then we have 50, 25, 12.5, 6.25, 3.125, 1.56, whatever, and then the next one is less than 1. So that's 1, 2, 3, 4, 5, 6, 7 half-lives. And I carried 5. 30, 40. What?
Wait.
10112.
And my ones jump together. 0, 21, 49 and 51. 40.
Yeah.
40,110 years. A long time. A long time. Yeah. So it's not very difficult today. Kind of easy, right? Some things have a very long half-life, some things have a very short half-life. So some things, the half-life is less than 1 second. And some things, the half-life is more than, 1,000 years. It's quite different. Okay. Have either of you guys ever heard of C14?
Yeah, to calculate the years of
Yeah.
the ground.
Oh, come on, somewhere. English.
The ground?
You could just say, Summer,
Yeah.
to calculate the age.
Yeah.
That's all. Yeah. So, what happens is, when something dies, the C14 decays. By measuring how much C14 there is, you can calculate how long they were dead.
But I think it's very common to calculate the age of
The soil?
yeah.
Don't know if you can use C14 for this. I think you might need something else.
Yeah, but they usually maybe it's Asian things like the Asian.
What you can do, if there's something in the soil, you can use it to calculate the age.
Yeah.
And then you can know that everything at this level
Yeah.
was maybe 10,000 years ago, for example.
Yeah, and then next level.
Next level will be more,
Yeah.
be older, and then this one will be less, something like that. Yeah. Did you study this C14 in school? Do you see? No. You heard of it though?
Yeah.
Okay. TV?
The kind of movie is to what's it? I can search the word.
No, C16.
Don't know.
The core.
The bomb?
Like
C4.
C60.
documentary.
Oh, a documentary.
Yeah.
Oh, okay.
Alexa.
What's C60, Ben?
Lucifer.
I know C4, yeah. What's C60?
It's the shade of a ball.
Is it? Never heard of this. The shape?
Yeah.
C60.
Molecule.
Oh! A molecule. What's so great about C60?
I don't know.
Is it important?
I don't know.
Okay. If C60 is a molecule, then maybe it's like organic?
You know, like diamond or
Ah, yeah. Uh-oh. Oh no, my plug. Where is it? It fell out. Did I get it?
Yes.
Alright, so you can start. What have I got? Ah, yeah, these are easy questions. Only take a few minutes and then we'll do the next lesson. No, wait, hang on, which lesson? Half-Life, isn't it? Yeah. Oh, well, did you get these questions finished yesterday?
no.
No.
We just talk a little bit and go to the chemistry.
Wait, we didn't finish this one.
Yeah.
Ah! You told me we were on Half-Life. We're not on Half-Life, we're still on this one. Summer. Right, I'll tell you what, just do Half-Life and then we'll go back to...
Sorry.
He told me we were doing Half-Life. We should have finished this first.
Yeah.
Yeah, okay, well look, do the Half-Life questions and then we'll go back to decay equation. Right?
How about next lesson?
After lunch?
No.
Tomorrow? Bring your laptop.
No. I mean, 12.
After lunch.
No.
12?
I think
Maths.
we have two is math or physics.
No. We'll do 2 physics now and 2 maths later.
That's great. That's great.
I think so. I think so.